going to start now. So welcome to lesson 3 of the refresher course. Today we're going to be talking about algebraic fractions and these rational expressions. Okay, so the algebraic fraction is going to look like this. So it's going to be a fraction, but it's going to have these algebraic denominators and numerators. So instead of like 2 over 3, we're going to have like x squared minus 9 over x minus 3 and so on. Okay, so just before we start, have a look at the 3 examples. Have a quick think. Which of these do you think is correct? Which do you think are incorrect? Now, you don't need to work it out, but just have a sort of a quick think about this. Which one sort of looks wrong, right? We want to be able to kind of, sort of thing like sort of have a quick glance at something when something's not quite right here, right? And I can tell you that this one is wrong. Right? Why is it wrong? Because you see, we have if this was like x squared over x, then one of the x's would cancel and we would just get x. But you see, we've got this 1 here, right? And so like this really should be 1 over x, shouldn't it? Right? So this one is definitely wrong. And this one's wrong too, because if we had like 2x over, x, then that would be 2, but we're missing this second. We're saying we can't leave that out. Okay, so we know that one's also wrong. Okay, and the one that's correct, actually, like we don't know that it's correct, but let's assume 1 must be correct, because if we're saying which are correct, then 1 must be. This one is probably the one that's correct, right? So let's have a look at why. So have a look. What we're going to do is just rewrite this thing again. And from yesterday and the day before, we were talking about, okay, so you have to see, this is an example of why we need to factorize stuff, right? And with this example here, well, if we were going to factorize this, like how would we factorize it? And it's like, it's clearly like the difference of 2 squares, right? Because we have a square, it's not a trinomial, and we don't have a common factor here. So this is the difference of 2 squares, x squared minus 3 squared over x minus 3. And then if we have a look at that, then this is like 2 sets of brackets, like x minus 3 by x plus 3. And then that's over x minus 3. And, if we had something like, 2x over 2, see, we have the same number on the top and bottom. So we can say 2 over 2 times x, right? We can just like rewrite that. It doesn't matter which way that you do the multiplication, right? Do we have to multiply 2 by x, then divide by 2? Or we can we divide 2 by 2? And then, so it doesn't matter which order we do that in. And that means that we can separate these two. These 2 over 2, this is the same as 1. So 1x, this is just x. So this is why we can cancel on the top and the bottom, like we do. Okay, I know you know this. This is just sort of part of the purpose of the warm up, right? Which just talk about familiar concepts, just to get that sort of sense in. So in the same way, what I'm going to do is use brackets. So I have these brackets on the top line, and I can put brackets around this thing on this. And when I say like putting brackets around something is just like considering that thing like just one number, okay? And now we see like the 1 number on the top line can cancel with the 1 number on the bottom line. And this leaves us with an x plus 3. And this is the answer. But only if x is not equal to 3. Have a think about this for a second. Why is x not allowed to be equal to 3? And the reason why x is not allowed to be equal to 3 is because if x was equal to 3, x minus 3 would be equal to 0. We would be having a fraction where we're dividing by 0. We can never do that. Now, why can't we do that? Let's think about a cake. Just draw a quick circle. Here's a quick circle. Now let's think about like dividing this circle like into quarters. 1 quarter. We're going to divide these things into quarters. So we take the thing and we divide it into quarters. 1 quarter would just be one of those. But what about like, sixths? 1/6. So we divide it into sixths, 1/6, or we divide it into like millionths, right? Right, one out of the lot. So this number in the bottom is saying into how many parts are we going to divide the whole? And so that's where the zero, how can you, what the parts mean? You could say 1/1 part, which means just don't do anything. This would be 1/1 here. But what does, in terms of fractions, what does dividing by zero means? It doesn't make any sense. So anytime we're doing algebraic fractions, we're going to have to look at the denominators and we're going to have to see where is this thing equal to zero? X minus 3 is equal to zero when X is equal to 3. So we're going to have the rule that X is not equal to 3. And this is the one thing that you have to remember. So when we do these questions, we're going to be using stuff that we knew before, but we're just going to have these special extra little conditions that we will apply that will mean that we can use the methods that we already know. Okay, so algebraic fractions work like number fractions, but we can never divide by zero. So what are we going to do? What are we going to check? Well, first of all, we're going to factor the top and bottom. We're going to just make sure the denominator is not equal to zero, and we're only going to we'll cancel the common factors, right? So we factorize, cancel things out, but we just make sure that we're going to cancel only the common factors. Okay, great. So let's get into a few examples. So we take our lesson from a couple of days ago and also from yesterday when we were looking at factorizing expressions. Now we see like a real context where we can use that. So what I'm going to do is draw the line of the fraction. And above the line, I'm going to do like sort of this question. And then below the line, I'm going to pretend that they're not part of the same question, right? So this first one, x squared minus 16. This is not a trinomial. There's no common factor. There's a minus sign. This is a perfect square. This is the difference of two squares, x squared minus 4 squared. This one here is x. The common factor is x, right? It's not a trinomial. We have an x as a common factor into x minus 4. Now, this is now the top line can be written as the difference of two squares. And what we see is that we have, this is a common factor on the top and the bottom. So we can cancel it out. And then we can say that this is equal to x plus 4 over x. And then we're done. But this can only be true if x is not equal to 4 and x is not equal to 0, because both 4 and 0s are ways that we can make this denominator 0. So if we put a 0 in here, we'll be dividing by 0. If we put a 4 in here, we'll be dividing by 0. So these are like essentially in our, in our graph or in our sort of problem here that we're working on. These are like trapdoors, right? So we have to rule out, we're like, just do not go to that place or that place. These are ruled out. Otherwise, you're good. So that's what we mean about adding a kind of a condition. So we say this is the answer so long as this is true. Okay, so with this one here, what we're going to do is we're going to add fractions. Now, before we add fractions, I'm going to take, right, I still have that. I'm going to take an example that we would have encountered before. I'm going to add 1/2 and 1/3. Now, 1/2 would be like splitting the cake in like this, and 1/3 would be like doing this. And the point is we're not able to add the two of them together. You can kind of see it kind of graphically. They don't really kind of fit, right? And what we need is we need to actually look at this 1/2 and we need to actually split up the cake further and realize that 1/2 is the same as 3/6. Now you might, like I'm not trying to be, you probably already know this stuff, of course, but when I do this sort of stuff, I try to kind of have maybe some sort of example that's so kind of simple and then connect connect this more complicated your thing that you're doing to something that's so much more simple, and it's just a memory. That's what helps you remember this thing when you have to remember so many other things as well, right? So if we can break it down to connect it to something totally stupidly simple, that's excellent news. That's exactly what we want to do. 1/3, we can see 1/3 is actually 2/6. And now you see we can actually combine the two. You see now we have like we can combine the two and we have 3 plus 2, 6. So that's just, like 5 sixths. Okay, fantastic. Now, how do we do that? Let's see how this is how we're going to represent it that graphically. What about doing this? What about doing this like algebraically, right? Like how are we going to do this if we had to do this algebraically? And what I'm going to do is write down the same thing again, and what I'm going to do is I'm going to multiply a fraction, like a fraction, something over something, right? Multiplied by this number, and a fraction multiplied by that second. So I'm trying to add these two, a fraction by this one, a fraction by this one. And, I can multiply any fraction by another fraction and not change that fraction if it's something over itself, right? Like if it was 5 over 5 or 10 over 10, then I wouldn't be changing this thing. I would just be, I'd be doing this trick, which would be changing from 1. So what is this number? Well, it's the other denominator, 3 over 3, 2 over 2. And that's what gives us the 3/6 plus 2/6 is equal to 5/6. So what we're going to do when we do this question is we're going to have a line here like this, and have a line here like this. And we're going to say, I'm going to multiply this fraction by like something over itself, the other denominator. The other denominator. And so you see, actually, now we just have, let's just draw it. We just have x times x plus 1. You see, this is the bottom denominator. And then this x plus 1 times x, this is x plus 1. And then this is 2 times x. So it's exactly the same. So this thing here, which you did like in primary school, can be applied to a leave insert question. Like these are literally up here at the end. I have some, or wherever they are, I have some leave insert questions which are like doing that. And that's great news. This is real understanding, right? This is when you understand something when it's not, when you're able to really kind of compress it in your brain and connect it to something that you already understand, and you just have to do like less work. Okay, so this is what understanding is all about. Okay, that's good news. Okay, where are we? Okay, so then if I just look now at the top line, I have an x and 2x. So I have, this is a 3x, and then I have a plus 1 all over x times x plus 1. And I can't go any further. I can't factorize. Like it isn't 3x. If it was 3x plus 1, I could, but I can't see it's 3x plus 1. It's not 3 times x plus. This is super important. Like, you know what I mean? Like have a lot of sensitivity to that. Like definitely you cannot go further, full stop, where we can't go further. Okay, sometimes you can, other times you can't expect that it has to go further than this. This is perfectly fine to finish on. Okay, great. Okay, what about subtraction? How is this going to change our approach? Need a little bit more space for this in here. Okay, so we're gonna have a number here. Gonna have a number here. So we have to combine these two fractions. And here I'm gonna have this x plus 2 over this x plus 2. And then I'm gonna have this, the other denominator, x over x. So exactly the same thing so far. I have one single line. X times x plus 2. Let's not forget our brackets. This is 3 times x plus 2. Now this question was talking about subtraction, right? this minus sign, this thing is causing the difficulty. That's what's going to go here. Now, observe what I've done. Like what I've done is I've said, maybe I'm not totally sure what to do with this minus sign, but I'm going to do everything else around it. And I'm just going to be left with the piece that I don't understand. That's a really excellent thing to be able to do because we shouldn't let something that's if there's something that we don't understand, it shouldn't mean that we don't do any of the question. In fact, we should do all of the question except for the bit that we don't understand. We should surround the bit that we don't understand, and then something's going to give, and it's gonna break open, and we're going to understand. Okay, so it's just a way to tackle the situation when you're not fully sure of what you're going to do. So just before we do it, let's say we take the case of like 2 over x, and we had like minus 2 over x. This is actually the same as if we had like x and we had the minus 2 up here. So what we're going to do is we're just going to think about this as being minus 1. So like this thing here, 3 over x, like minus 1 over x plus 2 is kind of the same as 3 over x plus and then minus 1 over x plus 2, if you see what I'm saying. So all that means is that we just have to multiply that minus 1 by the x. And then we get like minus x, you see. So we've been kind of given the same question as we had before, except instead of the plus sign, we had the minus sign. And then how do we deal with that? Well, it's just with the tiniest modification, right? So that might actually, if you saw that, you'd be like, look, I know how to do it when it's added. I don't know how to subtract. I have no idea. Actually, it's almost identically the same thing with just this tiniest change. That's a kind of a kind of, you should take a lesson from that. Like that's how a lot of times things are difficult, not because they're totally brand new. It's because they're totally the same stuff that you're able to do before, but just with some small little change. Okay, so now I can just continue on. So maybe I gave that more than it deserved in terms of explaining. And then this is like x times x plus 2. And this is like 2x plus 6, right? All over x times x plus 2. And this is like 2 times x plus 3 over x times x plus 2. And now we're done. We can't go any further. Okay, so the next one is to simplify this example. So let me just rewrite it slightly differently. Incidentally, in that previous example, x is not allowed to be equal to 0, and x is not allowed to be equal to minus 2, because that is 0 would make that dividing by 0, minus 2 would make that dividing by 0. Okay. And if we notice the top line, so we're just going to work on both lines separately. So that top line, we're just going to take out an x. It's not a trinomial. Bottom line, we're just going to take out an x. And then what we're going to do is we're going to notice that there's an x on the top and bottom. So we're going to cancel that x off. So we just have like x plus 5 divided by x plus 2. And if we look here at this bit and this bit here, well, we can't have x equal to 0 because that would make that bit 0, and we cannot have x equal to 2. Sorry, you can't have x equal to minus 2 because minus 2 plus 2 will be 0. So we just have to rule out the values of x. So this is the answer as long as x is not equal to 0, and x is these are like trapdoors for our problem. Okay. So you're probably already seeing the answer. If you're already seeing the answer, that's great. What happens with maths is that like when you hit the understanding, then you just can't forget it. And if you have to study this again, you're just reminding yourself, and you can kind of get back to where you were with it very quickly. I just put brackets around things to be safe. Now I realize that 2 times x plus 3 plus 5 times x. That first line is 2x plus 6 and plus 5x. The bottom line is still x times x plus 3. You might be tempted to multiply that out, but don't, because we need to express these things in their simplest form. And if we multiply that, we'd have x squared plus 3x. And then we'd be just like, well, I should just factorize that, you see? So sometimes you want to do that. Like if the bottom line happened to be like x squared plus, sorry, if it happened to be like x times x plus 3, like plus 5, then we would have to multiply that out and then maybe factorize again or something like that, right? But here, this is good. We can't make that simpler, so we're just going to leave it as that. And the top line becomes 7x plus 6 over x times x plus 3. And now we can't go any further. There's no common factor on the top line, so we can't make that simpler. We have to stop. Okay, so I'm going to stop talking there for a minute. And maybe have a go at a few of these questions here. And see how far you get along. Okay, so I'll tackle these questions now. X squared minus 25 all over x squared minus 5x. Okay, so I'm going to have to factorize top and bottom lines. Top line, this is not a trinomial. There's no common factor. This is the difference of two squares, x squared minus 5 squared, and then x over x minus 5. And then we have like x minus 5 by x plus 5 on like the top line, and then x times x minus 5. And then that cancels, and then you have like x plus 5 over x. And that's our final answer there, except we just have to also say that x is not allowed to be equal to 0, and x is not allowed to be equal to 5. Okay, same thing here. 3x plus 6 all over x squared plus 2x. So we have top line 3 into x. There is a common factor, so 3 into x plus 2. Bottom line x into x plus 2. We see that the x plus 2 is on the top and bottom, so we have 3 over x. That's our answer, except we have to say that x is not allowed to be equal to 0, and x is not allowed to be equal to minus 2, or else everything kind of breaks down. Okay, so now we have 1 over x, and we have plus 1 over x plus 4. And what we're going to do is have a fraction here and a fraction here. We have to put a number here and here. what is that number going to be? It's going to be the other denominator, x plus 4 over x plus 4, and then x over x. And then this gives us here, our denominator is going to be equal to like x times x plus 4, and then like x plus 4, and then a plus x. So this is going to be on the top line 2x plus 4 over x times x plus 4. And you know, if you went and canceled, that's a terrible mistake. So we don't have brackets here, right? So that's, you just have to, like, that has to be super clear, you know? So this is 2 times x plus 2 over x times x plus 4, and we can't go any further. And of course, we're just going to have the condition here that x is not equal to 0 and x is not equal to minus 4. Okay, so then the next one is 4 over x, and then the minus 2 over x minus 1. And then we're going to say, put the line here, the line here. Okay, what's going to go here and here? It's going to be x minus 1, the other denominator. Okay, as soon as we've done that, we have x times x minus 1. We've got 4 times x minus 1. We've got minus 2x. Okay, so that minus there isn't really causing a problem. It's just this. No, this could be, if this was x plus something, we'd have to be careful multiplying it into brackets, right? But otherwise, it doesn't cause a problem. And then this is like 4x minus the 4, and then minus the 2x. And then we have x over x minus 1. And then this is going to be 2x minus 4 over x times x minus 1. And this is finally going to be 2 times x minus 2 over x times x minus 1. Okay, and we can't go any further then. Okay, great. So the rest of the time now we can dedicate to answering some questions. See what we have, and we'll also look at, yeah, we have enough questions to look at here probably, and then we'll also take a careful look at the marking scheme as well. Okay, so we have one here. Find the value of the following expression when x is equal to 2, and give your answer in the form of a over b, where a is an element of a and b are both natural numbers. Now, the first thing that you notice is that this question isn't quite what we've already been doing. Like, what we've already been doing is much more like standard kind of book questions. But when you do the exam itself, they're going to put a twist on a standard kind of book question, which is going to say, okay, they're putting it up to you. They're like, okay, you know this thing. How about we ask it to you in this kind of weird way that maybe you haven't seen before? So they're going to throw you a curveball, like this baseball expression. So what are we going to do? Well, what we're going to do is just keep our heads and just do exactly what we did before, because we trust in the methods that we've learned, and we're going to trust that it will work in this context also. So let me write this out, 3x plus 5. If you're ever sort of like, if you ever want a kind of a quick way to kind of get going on a question, rewriting the question gives you a way to sort of examine it in a lot of detail. So what am I doing? Like, when I've done enough of these questions, I essentially kind of have something like a muscle memory, like a muscle memory in your brain, right? It's like a habit, right? So what I'm going to do is immediately do this thing that we were doing before. And I'm going to say, okay, so I'm going to multiply a fraction times the first one and a fraction times the second one. And what's it going to be? Well, it's going to be the other denominator, right? Let me put brackets around things if I need to. Okay. And then what about this 10? See, we didn't have a number just on, see, like that's what's a little bit not the same with this example, right? As we just go about the question, we start to we start to see what made us feel a little bit uncomfortable, right? We start to kind of shine light and everything, right? The only way to do it is just to go ahead and do the question, right? And then you see, oh, okay, I was worried about that thing, but you'll only see that when you've actually like started working on the question a lot of the time. Okay, we have the same denominator, 10 times x plus 3. So let's just combine it into one fraction, and then we have like x plus 3 times 3x plus 5, and we have minus, see, it's minus 1 times 10, as I was saying. That's how we handle those ones. Okay, brilliant. Okay, so now we need to multiply things out on the top line and simplify. And, you know, this is already factorized, but you see the 10 is out of it. You see, so it's not, the top line isn't factorized properly. We can see we can't cancel stuff, for example. So we're going to have to, multiply everything back out again, combine this 10 in, and then factorize again. Okay. So what are we doing here? So we're multiplying as it's this by this, this by this, this by this, and this by this. Okay. Now you might think I'm taking baby steps, but those lines, like having to draw those lines, took no time whatsoever, and it meant that I never really had to overexert myself, basically, right? So the whole maths test will be like basically doing like running a marathon. It's a whole bunch of small little steps. Not one of these steps in isolation should be difficult, right? So that's why I can add these little things. Okay, so now I'm going to draw my line again. You know what? Sometimes I even put in the things that I know is not going to be changed, So it's just this bit is the only bit that I'm going to change. It's going to be x times, that's going to be 3x squared. It's going to be x times 5, it's going to be plus 5x. Then it's going to be 3 times 3x, which would be 9x, and then like a plus 15. Let's go up here. This is equal to 3x squared, and then plus 14x, and then plus 5. Did I make a mistake? Nope. Now, can we go further? So let me just look at this thing here. Let's say it's going to be equal to brackets, 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 3x and x. That's the only way to spell the first one. Two numbers that multiply to give me 5 will just be 1 and 5. Like if it's, we're not going to do this unless we find some even factorization. So the question is, can we get 14 from this? Now, if I put the 5 here and the 1 here, this will be 15 and it'll be 1, and we can get 16, but we can't get 14. And if I put the 5 here and the 1 here, I'll get 3 and 5, which will give me 8. So actually, I can't get any further, so I'm going to stop now. Okay. Now, I've been spending so much time looking under the microscope, I've lost complete perspective on what I've been doing. So is this the answer? Well, the only way to figure out what's the answer, what isn't the answer, is to look and reread the question. Okay. So this is something that you're going to have to do at the end of doing the question, like, did I answer? So let's reread it now. And in some way as well, I never actually read it properly in the first place. I just said, well, no matter what, I'm going to have to do this stuff. So let me just going to go ahead. Now I'll go back and read it. So it says, find the value of the following expression when x is equal to 2. So this is the following expression, and x is equal to 2. And write your answer in the form a over b. Okay, so now I'm going to say, well, x is equal to 2. So let me put it in. I get like, this is 3 times 2 squared plus 14 times 2 plus 5 all over 10 times 2 plus 3, which is 5. So this is like 12 plus 28 plus 5 is 45 over 50. And you know what? I can cancel out a 5. I get 9 out of over 10. That's the answer. We have to give our answer in the form of a over b as a fraction. So we want to be getting a fraction out as our answer. A and b have to be natural numbers. This is correct. I can't get it in simpler form than that. In fact, this is probably also correct, but you always get it to simplest form. Okay. And in fact, we could have maybe even put in the value of x is equal to 2, like right here at the start, right? We could have said x was equal to 2 here and like here, and then we would have just had fractions and just had to combine those fractions and we would have gotten the same answer, right? So that also would have worked. So there were two ways to do this question. And that's where, like, if we really know what we're doing, if we're really sure what we're doing, we may see shortcuts and we may have to exert less energy in answering a given question, which means we have more energy to spend in the more tricky places where it's really, like that's where they're really filtering between the people who sort of really get it and the people who mostly get it, right? Okay, great. So let's have a look at our answer here. So in this question here, all they did was they subbed in the 2 straight away. They didn't even do this step of, so we took a longer route, but no problem. Maybe you take the longer route before you know the shortcuts. We certainly weren't wrong because we got the same answer. They say some correct substitution or work towards a single fraction will get you 2 marks out of 5. So remember what I say. This is the 5 is getting everything perfectly correct. The 0 is oh, well, I don't know how to do this question, so I'm not even going to do it. Like when you do the exam, I can't remember exactly what it is, but there's 6 questions in section A and 4 questions in section B. I believe you have to do 5 questions out of 6 in section A and 3 questions out of 4 in section B. I could be wrong, but maybe they change it every year. But you might be able to kind of have one question from section A that you're like, look, I'm not going to even bother doing this one because this is not my strong point, and you're not going to lose marks, right? You might just pick a top 5 or something like that. But if it's a question that you are doing that you can't avoid, don't get 0, like get 2, because often it's very easy to get to 2. And in our case, any kind of substitution or work towards a single fraction, even just doing this is work towards a single fraction. Like writing down, maybe even writing down the thing and even doing the 2 lines like that is indicating that you understand that you have to multiply both fractions by something. This is work towards, that can even be enough. Imagine you do this exam paper, you just write 2 lines. That's 2 marks out of 5. It's 40% for that question, right? So just be aware of the threshold for that low partial grade. Work towards a single fraction. And for the high partial grade, it's a fully correct substitution. So I think it would probably either be getting to here, for example, might do it, or just having subbed everything in, for example, would give it to you. And if you ended up writing 45 over 50, you would lose a mark. Okay, you get quite good at being able to understand where the threshold is answering these questions when you've looked at the marking scheme. And when you're like doing an exam, you're like, look, I don't really have so much time. I have to really get onto this other thing here. And you're like, what's my high partial? And you're like, fully substituting a formula, for example, that's often enough. And then if you just did that and not finish it off, you get like 6 marks out of 10 or 3 marks out of 5 or whatever. Okay, great. So write this one as a single fraction in its simplest form. So this is a leave insert exam question, which is exactly like the ones that we are already doing. If we're not sure what to do, like why we're not going to be incorrect to have, we're not going to get any marks, but we're certainly not going to be incorrect to rewrite the question. So I'm going to write here and here. What do we put here and here for this one? The other denominator. What do I put here and here? The other denominator. Once I've done that, let's not forget to put brackets where we need them. So then this is going to be okay. And that's how we handle the minus sign. Okay, so this is going to be minus x plus 1 over x times x plus 1. And now we're finished. We can't go any further. So let's have a look at the marking scheme. So this is 5 marks for this one. And you've got to get a low partial credit if you write down this thing here. So if you write, okay, well, I'd have to have the 2 denominators multiplied together. We just wrote down this, and that's all we wrote down. We're going to get x times x plus 1. we're going to get 2 marks out of 5, which is 40%. And like that might not seem like much, but if you did that in every single question, like, you know, you're doing this question. Imagine you do this question. Imagine you have no idea whatsoever what to do. Well, if you just wrote down this, which took me all of 2 seconds, I'm getting 40%. I'm getting 40% of the marks here. And if I went through the whole exam paper just writing down those little tiny things, which are like, well, this is probably going to be involved. It's probably going to have this. I'm going to pass the test. And you're going to, like, if you think about the amount of energy, you probably be able to do that in about, like, if you did it right, you could do it in about half hour, 45 minutes, where everybody, so you can get up to the threshold of 40% in about 20 minutes, 30 minutes, if you just scan through the entire paper and in every question did just a little thing in every single question, which was probably along the right lines, then that will be enough probably to get you a pass, which is great news. Like everybody should do that. That should be like basically you shouldn't go. That should be a net that you don't go under, basically, right? That's at the 40% level. Okay, and then for this question here, to have gotten to the single fraction, so to have gotten to this line here is the high partial credit. And it's also kind of good, like if you're like really I'm running short in time and like what is it that I have to get to get to the high credit, to get to this is the 60% level. That's also good to know. So here that's just, having combined the two fractions and having gotten to this stage correctly, but not having finished it off. Okay, so this one here is a little bit more, the way it's written, like it has all of this, what we would call sort of like extra kind of text, right? But let me show you what I think what I was, when I was doing Leaving Cert, this is the kind of stuff that I was doing. I was like, you probably just mean work on this, right? Let's just assume that you mean work on this. Let's just proceed. So this is equal to, and then top line, brackets, 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 brackets. And we need two numbers that multiply to give us, let's even, this is another thing that people should do sometimes. Let's just go over here and do some rough work, because I want to focus on this top line. And the way it is, if I try to get everything right in this amount of space here, it could mess everything up. Let me just separate out this tricky part and think about what can happen here, right? So, okay, so two numbers that multiply to give me 6, 1 and 6, or 2 and 3. Two numbers that multiply to give me 20, 1 and 20, 2 and 10, or 4 and 5. So it's some combination, maybe 1 and 6 and 2 and 10 or something like this. We also have a plus number here, which means that they both have to have the same sign. And we have a minus sign, which means that they both have to be, well, in this case, they're both going to have to be negative, right? Right, a negative sign. So what I'm going to do is I'm just going to say, let's go with that 6 and 1. Let's just go with that 6 and 1. So that's 6x and x. And now let's go through the possibilities. Can I have a -1 and a -20? That would be 6 times, okay, 120, definitely not going to work. 6 times 20, that was 6 times 1, that's 6. Okay, that's closer. 20 and 6 is 26. I can't get to 23 from 20 and 6, okay? So it's not going to be that one. Let's go to the next one. 2 and 10. 6 times 10 is 60, not going to work. Right, let's go to this one. This is going to be 6 times 2 is 12, and 10 times, so 12 and 10, I can get to 22, but I can't get to 23, so that's not right. So let's try 4 and 5. So this is 6 times 5 is 30, and this one is, so that's not going to work. And then the 4 and the 5 like this, 6 times 4 is going to be 24, and the 5, that's not going to work either. Now, this may seem like a long process. What we're using is trial and error here. And trial and error is okay to use if there isn't too many combinations. Right now, we're at the kind of upper limit for like the kind of example that we would use trial and error for, right? Because it is already getting quite long. I've ruled that one out. It's not that one. Okay, so it must be the other one. Okay, that's great. That's great news. Let's just move on. So we're going to do the same example this time now. we're going to do it with 2 and 3. So we're going to say that this is now equal to brackets, brackets, and we have like, let's say 3x and 2x. Okay, and then we have a 20. So let's just try this 1 and 20. That would be 60. That's not going to work. 20 and 1. That's going to work, isn't it? So minus 1 and 20. Oh, no, it's not going to work because that's going to be 40 and minus 3. So that's not going to work. Okay, close. So that one's out. So it has to be one of these two. So 2 and 10 minus and minus. I wonder if this even goes in. Oh, it has to. Okay, yeah. Okay, that's okay. So yeah, okay. I already can see something. 3x minus 2 and 2x minus 10. That's going to be 30 and 4 is not going to work. We put the 10 here and the 2 here. That's going to be 6 and that's not going to work. And then the final ones, that's not it. This is the very final possibility. If this doesn't work, we really are. So let's try a 5 here and a 4 here. And 3 times 5 is 15 and 2 times 8 is 2 times 4 is 8. So 8 and 15 works. And there we go. That's our factorization. We went through 6 possible versions of it, and it was number 6. That was just sort of bad luck, right? 3x minus 4 and 2x minus 5. And this is 2x minus 5 here. And then we see the 2x minus 5 cancels, and we were equal to 3x minus 4. Now we got something out of this. So this is the answer, and it's in the, okay, so let's have a look back at the question. This is the function h is as follows. It's just a function. We're calling it h. Normally we call functions f of x, but we don't really care. This one happens to be called h of x. Okay, doesn't matter, okay? And we want to express h of x in the form ax plus b, where a and b are an element of z. Okay, so we start with this. We factorize the top line. We cancel something out. This is what we got out. So what we're saying, h of x is equal to 3x minus 4. Have we answered the question? Well, we are expressing h of x in the form ax plus b, where a and b are integers. A is 3, b is minus 4. We have done what we've been asked to do. This is correct. Okay, we made a meal out of it, though, or I made a meal out of it. This is interesting. Why did we make a meal out of it? Tunnel vision. Okay, tunnel vision. We're committed to answering the question in the way that was most familiar from what we've been doing in this lesson. And we missed something. We missed this 2x minus 5. You see, this 2x minus 5 should have been telling us, well, we have to use this one, and we have to use that one, because there's a 2 here and there's a 5 here. So we should have gone straight to this one and not gone through all the previous ones beforehand. We just wasted all a lot of time. Now, it's okay to waste time. It's just, do you know what I mean? Like, if you don't waste any time in the exam, you could probably get it done in an hour and a half. But the time that they give you for the exam takes into account that you're probably going to be stressed. You're probably going to do things wrong because of just nerves and stuff like this. So it's actually designed so you could do it. If you did everything absolutely perfectly, you could do it probably in about an hour. But they give you 2.5 hours to take into account things like this, where you spend too much time. The real danger is not the time. The real danger is the effort, because it's something like, imagine you're doing a marathon. You said, you know what, I'm going to sprint the first kilometer. Well, you're not going to finish the marathon then, because you're not pacing yourself. So that's the real danger, that you end up exerting too much energy. And it might happen that you're in a question, you're like, you know what, I think I've probably gotten 7 marks out of 10. I don't want to do any more here because I'm exerting way too much energy. I'm going to come back to this maybe later if I have energy at the end, because I'm much better off getting these 7 marks out of 10 in 5 other questions than getting 10 out of 10 just in this one, and threatening the rest of them. So you can be sort of strategic like that. Okay, brilliant. So let's have a look here. So this is only 5 marks. Sometimes you see the amount of work that goes in, you're like, really, only 5 marks? But this is just the way it goes. Let's have a look here. Work of merit, for example, attempt to factorize the quadratic. So even if we just did something like a bit of this thing, like even if we just wrote that down, 6x and x, that's enough for 2 marks out of 5. So if you had absolutely no idea what to do and you were just like, yeah, probably something like this, I think maybe I cannot remember anything. This is already 2 marks out of 5. This is like 40%. You do this on every single question, you pass the exam. I can't say this often enough. I am going to keep repeating this point. Um, like pay attention to what that low partial grade is because you wouldn't believe how, if you approach it correctly, you can get. And by the way, I do say this in some of my tips. Let's say, for example, you're going for a course, like maybe you're going for a course. I can't think of one. Maybe it's in arts or history or something like that. You need maths. You don't need, you're not going to use it ever, but you need it to get into the course. But you actually need like whatever it is, like an O6 or an O4. If you understand the marking scheme, if you understand how to get to the low partial credit, which is just looking at it and seeing what we're doing here, um, if you're always getting the low partial credit, that's 40%. That's like an O6, right? If you're always getting to here, this is like 60%. This is an O4. So you might be like, you know what, if I can just do this exam and for most questions I get to the high partial credit and then sometimes I finish the question, I'm going to clear my O4 criteria. And you know what, I'm actually relying on this to get the points. And so you can actually kind of sort of be very sort of strategic about the amount of effort that you want to put into your subject if you understand the marking scheme. This is why I emphasize it so much. Okay, what about getting to the high partial credit? So correct factors of the quadratic. So if we get down to there, we've gotten the high partial credit. We've gotten the 3 out of. So it's a little bit like imagine you're trying to get from, let's say, from this land mass to this land mass here, and this is 0, and this is like full marks 5, and here you are, and you're like, here's a stone, and this will be worth 2, and this one here will be worth 3, and you're like, okay, what's this jump involved? Okay, I make that jump. And you're like, you know what? I've just gotten the 2 out of 10. I'm going to stop here. But then you're like, well, I can see how I can get to that one. Like, gonna now, if you make the mistake, like you actually kind of you sort of try to, you can end up the in my analogy here, like sort of jumping in the water. It just means that you end up sort of trashing about and spending energy and just not getting any marks for it, basically, right? So that's where understanding the marking scheme can be super helpful in terms of managing your time and energy. And also being very targeted in what you want to achieve with this, right? Brilliant. Okay, so this is we've got 2 more. I think we'll just get this one done. This one here looks like a bit weird. This is a section B question, and if we read it, we have something about the surface of the third solid is made up of H hexagons and P pentagons and blabbity blue, and use this equation to find the number of this thing, like whatever. Like this is where I'm sort of like, I don't care about any of what you just said there, right? I'm just going to look at this and I'm just going to try to do some sort of algebra with this. Okay. So let's work on, let's say, this piece and just preserve everything else. So we've got 6h plus 5p over 3. We've got minus 6h plus 5p over 2. And then we just have everything else. Plus 5, plus, let me just give myself a bit of space, plus p is equal to 2. And this will be the other denominator 2 over 2. And this will be 3 over 3. And so when I multiply out that first one, I'm going to have like 12h plus 10p over 6 minus, and then 18. Well, let's just do minus 3 times 6h plus 5p. And I'm just going to bring that stuff to the other side, 2 minus h minus p. Okay, so this is now 12h plus 10p, and then minus 18h. And here's where you go wrong. See, that's minus 3 times 6h, minus 3 times, this is minus 15p, all over 6 equal to 2 minus h minus p. And then I multiply across by the 6, 12h. Now that's 12h minus 18h is minus 6h. 10p, that's minus 5p. 10p minus 15p. Then this becomes 12 minus 6h minus 6p. Okay, now I'm going to bring everything, all the h's and p's over to the right-hand side. So minus 6h, and then this minus 6h becomes a plus 6h. Minus 5p, and this minus 6p becomes a plus 6p. That's equal to 12. So you see all the h's and p's, all these guys are over on the left-hand side, all the numbers are on the right-hand side. And now when I look at this, then the h's cancel. And the minus 5p, this is p, is all left, equal to 12. You see? This whole monster here, that thing, is another, it's just a complicated, convoluted way, and people can often find complicated, convoluted ways of saying things, of saying p is equal to 12, okay? And when we just do our algebra that we know what to do, then it all sort of unravels. So if we have a look at this, the low partial credit was a mention of the multiply both sides by the 6. So that step that I did, of, or else, yeah, they were sort of saying multiplied by the 6 in the first place. We basically, for having done some of this work here, like that would be enough for the low partial credit. Mid partial credit is that step when I multiply across by the 6. That thing multiplied across by the 6 will be enough for the mid partial credit, which would be 5. And then once we get an equation with everything, so once we get down to like this line here, basically, that's enough for the high partial credit, which is like 8 out of 10, 10 out of 10. Like it's almost the same thing. And just very quickly, very, very last one. So we have, you're never wrong, just rewriting 7x minus 5 minus 4 times 3x plus 1. Now I'm going to take, by the way, using multicolored pens, some people I kind of need colors. I'm kind of a bit peculiar in that way, maybe, if you want to call it that. It helps me sort of break things apart, so whatever works for you, like 7x minus 5. And now we're going to do this sort of stuff like this. Put brackets everywhere we need them. Putting brackets all around each of the expressions. So we have 3x plus 1, 7x minus 5, 2 times 3x plus 1, minus 4 times 7x minus 5. And we're just on time, so I'll just finish there. But we just multiply everything out. At this stage here, I'm at the high partial credit. Often when I'm doing questions, I just stop at the high partial credit because I'm like, finishing this off is just a matter of multiplying everything out. Okay. So let's have a look here. 10 marks. 3 marks is the low partial credit. Some work of merit, for example, writes the lowest common, basically sort of multiplying out those two, for example, like having taken some amount of this first step would be enough to get the low partial credit. And then the full second line, and so getting to here, so getting to here, as I said, this is the high partial credit. That's 7 marks out of 10. And you could stop there, because you might be like, look, I've really got to move on. Like my objective here is to get an 06. I need to get at least 60% in every part of the question. Now I've got 7 out of 10. I've done enough for this question. Now I can move on. Okay. So have I got a slide on a recap? Okay, no. So anyway, so what we did today anyway was we were simplifying these algebraic expressions. We were factorizing the top and bottom. We were canceling stuff out, and then we were avoiding these denominators equal to 0 stuff. And then we used that in a few exam questions where we had an equation, for example. So I'm going to stop there. Tomorrow I'm going to do coordinate geometry. So we'll have a little bit of this factorization stuff to do there. So that's it. So any questions, just drop it into a mail to me, and then I'll see you tomorrow at the same time.